In this example, we've got quite a few things to consider. We want to use that general term equation, and we have the sequence 2, 9, 16, 23, 30, etc., etc. It's an infinite sequence. And we've got these 5 items to take care of. First, we want to show that the sequence is arithmetic. So we'll talk about how to do that. We want to find a formula for the general term u sub n, and we want to find the 100th term for the sequence. And we're going to have to use that formula because I don't know about you, but I don't want to count increase. Looks like I'm going up by sevens. I don't want to count by sevens for 100 times. I'd rather use the formula. And then we're going to tackle these 2 final questions that are kind of the same. Is 828 a term of the sequence? And is 2341 a term of the sequence? So that's what we're going to do coming up right now. So let's start off by showing that the sequence is arithmetic. And if you remember from that algebraic definition of a sequence, we said that a sequence is arithmetic if and only if, and we kind of write if and only if with 2 f's because it's fun to do that, if and only if the difference between u sub n plus 1 minus u sub n is equal to some common value. So really what I need to do in order to prove this is I need to take a few of these terms and just find the difference between them. So we're going to just take a couple of these at a time. So let's take a 2 and 9. I want to show that 9 minus 2, the difference between that is 7. And let's take another 2 consecutive terms. Let's take 9 and 16. 16 minus 9, that's equal to 7. And you know what, just for good measure, let's take one more pair of consecutive terms. 23 minus 16, that's equal to 7 as well. What do you know? So these are all having the same common difference. Therefore, this is arithmetic. And that's really all you need to do to prove that this thing is arithmetic. All right, that takes care of A. Next up, we want to find a formula for the general term u sub n. So remember we had that equation we talked about in the last video. U sub n is going to equal u sub 1 plus your difference times n minus 1. So really, essentially what we need to do here is we need to kind of figure out what values we can assign this u sub 1, this d to, and then that's really it. The n is kind of like the variable. It's the index, so we're not going to actually plug in a value for n. And u sub n is what that spits out when I plug in a value for n. So we just need to figure out what these 2 things are. U sub 1 is easy. U sub 1 is the first term. And we have the first term. That is 2. So u sub 1 equals 2. We need to know what the common difference is. We did that in the last problem. We figured out the difference between all of these terms is 7. So let's plug it all in. U sub n is going to equal 2 plus 7 times n minus 1. And we can't really just leave it like this because we can simplify this. So I'm just going to push this 7 through, and I'm going to call this u sub n is going to equal 2 plus 7n minus 7. Or in general, u sub n is going to equal 7n minus 5. And that's it. This will help us generate all of these terms in the sequence. And it's always a good measure if you've got extra time to just check that this works. So let's look for the, I don't know, the third term. And hopefully we'll get 16. So u sub 3 should be 7 times 3 minus 5. That's going to equal 21 minus 5, and that is equal to 16, so it looks like it works. Okay, next up, we want to find the 100th term of the sequence. And the reason why we're kind of doing these in succession is because I'm going to use this formula that I just ended with here. So let's actually grab that formula. U sub n is going to equal 7n minus 5. So rather than count by sevens all the way up 100 times, we're just going to plug in 100 in for n. So u sub 100 is going to equal 7 times 100 minus 5. And again, just with the notation, this means the term of the sequence that is in the 100th position. It is the 100th term in the sequence. That's what this means. So this is going to equal 700 minus 5. So u sub 100 is going to equal 695. That's it. And then this is where we get a little bit more complex, but I think once you see an example, it should kind of make sense. We want to know if this is a term in the sequence. And again, rather than counting by sevens until I hit 828, maybe, what we can do is we can assume 828 is a term in the sequence. in this u sub n. Let me try those brackets again. Is a term in, there we go, u sub n. Much better. All right, and what I mean when I say that is we're going to actually use that formula, and I'm going to use this 828. So I'll say 828 must equal some 7 times n, and then I think we had minus 5. Yep, minus 5. So we're kind of assuming that this equation will at some point equal 828 for some value n. So let's just solve for n. We're going to add 5 to both sides. So I get 833 is going to equal 7n. And this might be a good point to grab that calculator. I'll divide both sides by 7. And I get, let's see, I've done this out already, and I get n equals 119. So what does that mean? Because this came out to be a natural number, or you can remember a natural number is like a positive integer, that means that at some point this is going to show up in your sequence. Actually, this will be the 119th term. So not only did we find that this comes out to be an integer, that proves then that this is actually a term in the sequence. So to answer this question, yes. And I guess we could say down here, 828 is the 119th term in this sequence. So that kind of sets that, that settles that debate that we were having with ourselves. So, okay, well, let's look at this next example. And I have a feeling this one might not work out since the last one did. We're going to do the same things we did before. We're going to assume that 2,341 is a term. So therefore that we must have 2,341 is going to equal 7n minus 5. And then the standard order of procedure is to, or excuse me, the standard operating procedure is going to add 5 to both sides. So I'll get 2,346 equals 7n. And now at this point when I divide both sides by 7 and you pull out that calculator, you end up getting, see, I have written down n is going to equal 335 and a seventh. So I'm not a big fan of the mixed number, but really the key is that it does not come out to be, if you type this in your calculator, you're going to get a decimal, 335 point blah, whatever a seventh is. And that tells me that if I were to be counting by sevens, or if I were counting the terms in this sequence, I'm going to fall somewhere before and after 2,341. I'm not going to actually hit 2,341 because this is not a natural number. Therefore, 2,341 is not a term in the sequence. So that's really all that you're looking for. When you actually assume that it's in the sequence, does it come out to be a natural number? That's it. So lots of parts to this problem, but hopefully you're seeing that they kind of all flow into each other, and it's really not all that taxing as long as we know how to use these formulas correctly. So why don't you give this problem a shot? It's again 5 parts. Pause the video and see how it goes. All right, and here are all of my answers for this example here. Hopefully it went okay.